Within each cell of your body resides a hidden mechanism poised to extend your lifespan. Autophagy. When scientists finally unraveled its workings, they bestowed upon it a Nobel Prize. Surprisingly, most individuals will never trigger this process, not due to inability, but because they are unaware of its initiation. You've likely heard of fasting and its profound health benefits, yet here's a secret no one tells you. The transformation doesn't begin the instant you cease eating. Your body follows a precise timeline, a biological countdown that dictates the precise moment your cells switch from consumption to cleansing. Miss this crucial window, and you're merely hungry. Hit it correctly, and you unlock one of science's most potent anti-aging mechanisms. The term autophagy literally translates to self-eating, which may sound unsettling. However, this isn't your body destroying itself. It's a far more intricate process. Your cells dismantle damaged components, repurpose their elements, and reconstruct themselves more robustly than before. So, when does this actually commence? After 8 hours? 12 hours? 24? The answer astonished even the researchers who dedicate themselves to its study. By the end of this video, you will grasp the exact moment your body initiates this cellular detoxification and, more importantly, how to leverage this insight for a healthier, longer life. Before delving into the timeline, it's essential to comprehend autophagy's function. Once you witness the cellular transformations during this process, your perception of food will be forever altered. Every second of your existence, your cells generate waste. Damaged proteins accumulate, mitochondria, the minuscule energy producers, begin to malfunction, and toxic molecules build up. It's akin to residing in a house where refuse progressively fills every room. Your body possesses an inherent cleanup system for this, present since birth. The challenge, however, is that this system only activates under specific conditions. Constant eating, breakfast, snacks, lunch, more snacks, dinner, dessert, keeps your cells in a perpetual state of construction. They're too occupied processing nutrients to halt and clear the debris. Autophagy occurs when your cells finally get a respite. Specialized structures called autophagosomes form within each cell. Imagine them as microscopic refuse vehicles. They identify compromised proteins, worn-out mitochondria, and cellular debris. Subsequently, they encircle these compromised parts, seal them, and transport them to recycling centers known as lysosomes. Within the lysosomes, potent enzymes break down everything into fundamental constituents: amino acids, fatty acids, and simple sugars. Nothing goes to waste. Your body transforms damaged and hazardous elements, completely disassembling them and repurposing them into something novel and operational. It's molecular recycling at its zenith. What makes this process so impactful is that when autophagy functions correctly, it doesn't merely eliminate waste. It specifically targets the most damaged and dangerous cellular components first. The proteins potentially leading to Alzheimer's, the mitochondria generating detrimental free radicals, the cellular debris instigating inflammation and aging. Scientists now believe that when autophagy falters, diseases emerge. Cancer, neurodegeneration, heart disease, and accelerated aging are all linked to cells that can no longer efficiently cleanse themselves. Thus, activating autophagy isn't solely about feeling better. It's about averting the cellular damage that precipitates the diseases most people dread with age. And the key to its activation? Time. Specifically, time without sustenance. Yet, this is where timing becomes paramount. The discovery of autophagy was not instantaneous. For decades, scientists recognized that cells had some form of waste management, but the specifics remained elusive. Then, in the 1990s, a Japanese researcher named Yoshinori Ohsumi began experimenting with yeast cells, and everything shifted. Ohsumi performed a simple yet ingenious experiment. He deprived yeast cells of nutrients and observed the outcome under a microscope. What he witnessed was extraordinary. The cells didn't simply succumb. They began to consume their own internal structures, but in a controlled, deliberate manner. These tiny organisms were performing self-surgery, dismantling damaged components, recycling the materials, and utilizing them for survival. Osumi dedicated years to meticulously mapping out this process, identifying the genes and proteins involved at every stage. His pioneering work earned him the Nobel Prize in Physiology or Medicine in 2016. However, the true revelation came when other scientists made an astonishing realization. Humans possess the identical autophagy system, the same genes, proteins, and cellular machinery. This process has been intrinsic to your being your entire life, refined over millions of years of evolution. Your ancestors endured famines because their cells could strategically consume themselves, breaking down the unnecessary to preserve the vital. That same survival mechanism remains active today. The dilemma? Modern life rarely triggers it. Our constant eating prevents our cells from receiving the signal to initiate cleansing. They remain in growth mode, building and storing, never repairing and recycling. And that is where the timeline becomes crucial. So, here's the direct answer you sought. Autophagy begins to activate for most individuals between 12 and 16 hours of fasting. But it doesn't reach its full potential until 24 to 36 hours. That's when genuine cellular repair takes place. Now, let me elucidate what transpires within your body during this window, as comprehending the process transforms everything. The moment you stop eating, your body doesn't immediately consider time for autophagy. A very specific sequence of metabolic events must unfold first. In the initial 4 to 6 hours after your last meal, nothing unusual occurs. Your body continues to utilize glucose from that meal. Insulin levels remain elevated, signaling your cells to grow and store energy. Your liver retains ample glycogen, that reserve battery of stored sugar. Everything is normal. Around hours 6 to 8, changes commence. Blood sugar stabilizes, and insulin begins to decline. Your liver starts releasing glycogen to maintain energy levels. You might feel entirely fine, perhaps even invigorated. Your body hasn't yet detected an emergency. But by hours 8 to 10, the first indicators emerge. Glycogen stores are diminishing, and insulin has significantly dropped. Internally, molecular sensors begin to take notice. These sensors, proteins named AMPK and mTOR, function as energy detectors, continuously monitoring nutrient abundance or scarcity. When AMPK detects low energy, it activates. When mTOR, typically promoting cell growth, senses low nutrients, it deactivates. This interplay is crucial. AMPK on, mTOR off. This is the biochemical cue signaling your cells to shift from growth mode to maintenance mode. At this juncture, around 10 to 12 hours, autophagy subtly begins. It's not yet fully active, but the mechanisms are warming up. A few autophagosomes start to form. Some damaged proteins are marked for removal. Your cells are probing the situation, preparing for what lies ahead. Most people never advance beyond this point. They consume breakfast 8 or 10 hours after dinner, halting autophagy before it truly begins. They never uncover what transpires when the body delves deeper into this state. However, those who persist in fasting experience something remarkable. By hours 12 to 16, autophagy truly awakens. Your liver's glycogen is depleted. Your body fully transitions to burning fat for energy, and your liver begins producing ketones, those powerful molecules capable of fueling your brain when glucose is scarce. This metabolic shift is the catalyst. With low insulin, rising ketones, and energy derived from fat instead of sugar, your cells receive a clear message. Cease building, commence cleansing. Autophagosomes now form more aggressively. Damaged proteins are broken down more rapidly. old mitochondria are identified and slated for recycling. At 16 hours, many intermittent fasters conclude their fast and eat, and that is a viable strategy. By this point, you've activated significant autophagy. Your cells have had sufficient time for basic cleanup. Inflammation markers start to decrease. Cellular repair begins throughout your body. But if you extend to 18 or 20 hours, the intensity amplifies. More autophagosomes, more recycling, more cellular renewal. The cleanup that started as maintenance evolves into renovation. Your cells are no longer merely removing waste. They are actively upgrading their internal machinery. Some individuals report feeling sharper at this stage, with enhanced mental clarity. This is not imagination. Ketones provide a more stable energy source to your brain than glucose, and autophagy in your neurons begins to clear out the protein clumps that contribute to cognitive decline. Your brain is literally cleansing itself while you fast. Wait until you discover what happens at 24 hours. A full day without food. For many, this sounds extreme, but biologically, this is where autophagy becomes a powerhouse. By now, your body is fully committed to fat metabolism. Ketone production is vigorous, and your cells have had ample time to complete deep, thorough cleaning cycles. At 24 hours, autophagy is no longer simply removing damaged proteins. It's addressing entire structures. Mitochondria that have been inefficiently producing energy, concurrently generating harmful free radicals, are finally dismantled and recycled. This process, known as mitophagy, is crucial for longevity. Consider it this way. Your mitochondria are like tiny engines within every cell. Over time, these engines wear out. They start to misfire, producing less energy and more toxic waste. In a normal, constantly fed state, these compromised engines simply continue to operate, gradually poisoning your cells. During autophagy, your cells finally disable their most worn-out engines, deconstruct them, and either restore them or make room for new ones. This process resembles substituting a faulty car engine rather than merely adding more oil and hoping it functions. Your immune system also undergoes significant alterations after 24 hours. Research indicates that a full day of fasting can initiate the degradation of old, inefficient immune cells. Afterward, upon resuming eating, your body generates new replacements. It's akin to updating your immune system's software, eliminating flawed code, and installing a pristine version. The advantages for the brain are equally remarkable. Brain-derived neurotrophic factor, BDNF, levels substantially rise during extended fasting. This protein acts as a fertilizer for neurons, aiding their growth, establishing new connections, and reinforcing their resilience against damage. Elevated BDNF levels are associated with enhanced memory, accelerated learning, and protection against neurodegenerative conditions. Some researchers hypothesize this is why fasting has been connected to a diminished risk of Alzheimer's. When neurons regularly engage in autophagy, they eliminate beta-amyloid plaques and tau tangles, the harmful proteins characteristic of Alzheimer's. This preventative action occurs at the cellular level, silently safeguarding your brain decades before symptoms would manifest. However, 24 hours isn't the maximum. Extending to 36 hours further intensifies autophagy. Before delving deeper, I'm curious about your perspective. Given that your body initiates profound cellular repair after 24 hours, would you contemplate a one-day fast to trigger this process? Comment 24 hours to reset if you'd attempt it, or if it sounds too extreme for you. By 36 hours, an extraordinary phenomenon occurs. Growth hormone levels surge dramatically, sometimes increasing fivefold above baseline. This hormone not only builds muscle, but also shields existing tissues while promoting fat breakdown. Your body achieves remarkable efficiency in preserving crucial elements, muscle, organs, bone, while aggressively targeting fat reserves. At this stage, autophagy accesses structures previously unreachable. Protein aggregates that have accumulated over years are finally dismantled, and cellular waste hidden in inaccessible areas is cleared. Your cells perform intricate self-surgery, excising all non-essential components to retain only what is functional and robust. The mental effects at this point can be striking. Many individuals report an almost euphoric clarity, a focused calmness distinct from their usual consciousness. This is not merely psychological. Your brain is now operating on an entirely different fuel system, one that generates less oxidative stress and provides more stable energy. Evolutionarily, this makes perfect sense. When food was scarce, our ancestors required sharp minds for effective hunting and gathering. A clouded, confused brain simply couldn't procure sustenance. Thus, evolution designed fasting to amplify mental performance, not diminish it. That same ancient mechanism remains active in your modern brain. Now, here's the crucial insight. Beyond 36 hours, the benefits tend to plateau for most individuals, and the risks begin to escalate. This is where autophagy ventures into potentially precarious territory. There's a distinct boundary between autophagy and starvation, and comprehending this boundary is vital. On the surface, they appear similar. Both involve abstaining from food. However, biologically, they are entirely dissimilar processes. Autophagy constitutes controlled renewal. Your body meticulously selects what to break down: damaged proteins, worn-out organelles, superfluous cellular debris. It intelligently recycles these components, transforming waste into valuable building blocks. Muscle tissue remains protected, and vital functions proceed unimpeded. Your body is optimizing, not destroying. Starvation sets in when fasting extends too long. The body exhausts its fat reserves and begins to dismantle healthy tissue, including muscle, purely to sustain essential organ function. Hormone levels plummet, the immune system weakens, and mental function deteriorates. What was once a tool for health becomes a grave threat to survival. For most healthy individuals, the safe and effective window for autophagy lies between 16 and 36 hours. This time frame provides your cells with ample opportunity to execute significant cleanup without pushing your body into a state of emergency. Beyond 72 hours, you enter a domain where medical supervision becomes imperative. The key is to grasp that prolonged fasting does not equate to amplified benefits. Autophagy has an optimal range, sufficiently long to trigger profound cellular repair, yet brief enough that your body retains abundant resources to function. It's about strategic stress, not severe deprivation. Thus, the practical takeaway is this: you don't need to fast for days to reap autophagy's benefits. Consistent, shorter fasts can prove equally effective over time. Many individuals find success with time-restricted eating, condensing all meals into an 8-hour window daily. This entails a 16-hour daily fast, sufficient to consistently activate autophagy without the difficulty of skipping multiple meals. Your cells receive regular cleansing sessions while you still savor satisfying meals. Others opt for the 5-to-2 approach, eating normally 5 days a week and undertaking 24-hour fasts twice weekly. This offers more profound autophagy sessions while seamlessly integrating into most lifestyles. You might fast from dinner one day until dinner the next, providing your body a full day of cellular repair. There's also the occasional 36-hour fast, performed monthly or quarterly, for more intensive cellular renewal. Consider it akin to deep cleaning your home. Daily tidying keeps things manageable, but periodically, you need to relocate furniture and scrub areas normally out of reach. However, fasting isn't the sole trigger for autophagy. Exercise activates similar pathways. High-intensity workouts temporarily deplete glycogen and induce cellular stress, prompting cleanup mechanisms. Your cells respond to this stress by eliminating damaged components and strengthening remaining structures. Certain compounds also support autophagy. Coffee, particularly during a fast, contains molecules that activate AMPK, the same energy sensor that initiates cellular cleanup. Green tea functions similarly. Even compounds present in foods like turmeric, berries, and dark chocolate have been shown to bolster autophagic processes. Sleep might be the most underestimated autophagy trigger. During deep sleep, especially within your brain, autophagy activates to clear out metabolic waste that accumulates during waking hours. This explains why insufficient sleep is linked to neurodegeneration. Your brain requires these nightly cleansing sessions to sustain long-term health. Therefore, the complete picture of autophagy extends beyond just fasting. It involves cultivating a lifestyle that furnishes your cells with consistent opportunities for repair. Fasting is the most direct trigger, but it works synergistically with exercise, quality sleep, and judicious food choices. Now, let's dissect the comprehensive timeline, as understanding the progression aids in maximizing benefits. Hours 0 to 8. Your body relies on recent food intake. Insulin levels are elevated, cells are in growth mode, and autophagy is minimal, limited to basic background maintenance that occurs even when well fed. Hours 8 to 12. Glycogen stores begin to deplete. Insulin levels drop, and AMPK starts to activate. Autophagy begins to stir, preparing for the impending transition. Hours 12 to 16. Glycogen is mostly exhausted. Fat becomes the primary fuel source, and ketones start to materialize. Autophagy awakens, with autophagosome formation occurring more frequently. This is the common duration for most intermittent fasters, and it's sufficient to initiate significant cellular cleanup. Hours 16 to 24. Autophagy intensifies. Damaged proteins are broken down faster, mitochondria are recycled, and inflammation markers decrease. The brain begins to operate efficiently on ketones. This extended period facilitates deeper cellular repair. Hours 24 to 36. Peak autophagy. Growth hormone surges. Immune cells regenerate. The deepest cellular structures undergo renovation. Your body is now performing major maintenance, not merely routine upkeep. Beyond 36 hours. Autophagy persists, but benefits plateau while risks escalate. This domain necessitates careful consideration and often medical guidance. The timeline is unequivocal. Autophagy commences around 12 hours, becomes significant at 16, achieves high efficiency at 24, and peaks around 36. Subsequently, you are pushing into territory where more does not necessarily equate to better. If you are new to fasting, start with 12 to 14 hours and gradually increase. Allow your body to adapt progressively. The objective is not to endure hunger, but to train your metabolism to efficiently oscillate between fed and fasted states. Maintain adequate hydration during fasts. Water, black coffee, and plain tea do not break a fast and can actually bolster the process. Electrolytes, particularly sodium, potassium, and magnesium, become crucial during longer fasts. Listen to your body. If you experience dizziness, extreme fatigue, or feel unwell, discontinue the fast. Autophagy is potent, but it's not worth compromising your immediate health. The benefits derive from consistent, long-term practice, not from disregarding warning signs. And remember, autophagy is merely one component of the health mosaic. It performs optimally when integrated with nutrient-dense foods during your eating windows, regular physical activity, quality sleep, and stress management. Fasting triggers cellular cleanup, but your actions throughout the rest of the time are equally vital. The science of autophagy unveils something profound about human biology. For millennia, we evolved in environments where food was not perpetually available. Our bodies cultivated this incredible repair system to capitalize on those lean periods, transforming scarcity into an opportunity for renewal, rather than merely subsisting until the next meal. Modern life has entirely disrupted that rhythm. We eat from the moment we awaken until we sleep, maintaining ourselves in a perpetual growth mode, never affording our bodies the respite to cleanse the damage that inevitably accumulates from simply being alive. The repercussions manifest as age-related illnesses, metabolic disorders, neurodegeneration, and cancer. By strategically choosing to fast, you are not denying yourself anything vital. Instead, you are reconnecting with an ancient biological wisdom, granting your cells the freedom to perform their inherent functions, repairing, rejuvenating, and optimizing themselves internally. The next time you experience hunger during a fast, remember the underlying process. These sensations do not signify weakness or failure. They are indicators that your body is changing modes, shifting from intake to creation, from construction to restoration. With every hour you endure beyond the initial discomfort, millions of cells throughout your system are actively working to enhance your health, strength, and resilience. If you are intrigued by the transformative effects of fasting on your body, you must see this next video. What happens to your immune system during fasting? Science explained. It perfectly complements the information presented here, illustrating how immune cells literally regenerate themselves while you fast. Believe me, it is one of the most overlooked aspects of fasting. After decades of research, most scientists concur. The optimal period for significant autophagy ranges from 16 to 36 hours of fasting. This is the window where your body transitions from burning fuel to profound restoration, sufficiently long to initiate the cellular cleansing, but brief enough to prevent harm. Short, daily fasts, such as the 16-8 method, maintain regular cellular tuning. Occasional 24-hour fasts boost resilience, and for those who are medically sound and experienced, a 36-hour fast can provide a complete autophagic reset. Beyond this duration, professional oversight and expertise become crucial. The profundity of this process is not solely biological. It resides in its consistency. Autophagy is not a singular event. It is a recurring pattern. The more your body acclimatizes to this rhythm, the more proficient it becomes at self-protection and renewal. Therefore, the next time you consider skipping a meal, keep this in mind. You are not depriving your body. You are providing it with an opportunity to heal itself from within. If this video helped you grasp how fasting activates your body's latent repair system, please hit the like button, subscribe for more in-depth scientific explanations, and share this video with anyone interested in fasting and longevity. You might just motivate them to embark on their own health journey.